I grew up in the suburbs of Omaha, Nebraska, about 4.5 miles and in the flight line of Offutt Air Force Base. I loved living there, mainly because I could see and identify just about any plane that flew overhead. Each year I was a devoted attendee to the annual air show, where I saw the U.S. Navy Blue Angels, the U.S. Air Force Thunderbirds, and ultimately, I wanted to be one of those pilots. I've traveled commercially all over the United States, to Hawaii, to Mexico, and to Europe. I've contributed to the increase in aviation fuel use each year, as well as the increase in aircraft carbon dioxide emissions from 0 to 700 million metric tons. In 2010, aircraft operations accounted for 2 to 3% of total global human-induced carbon dioxide emissions, which is equal to the percentage of emissions from the combustion of coal, natural gas, oil, and other fuels in Canada and Mexico combined. If ground support equipment, upstream fuel consumption, routine maintenance, and aircraft manufacturing are included, the contribution of the air transportation industry to global emissions increases even further. In at least the last 800,000 years, there is a clear relationship between human activities and increased concentrations of atmospheric greenhouse gases. Since at least the 1990s, numerous reports have been conducted on climate change, including those by the Intergovernmental Panel on Climate Change, the IPCC. Current and future emissions relate directly to future global surface temperatures, more hot days, and more frequent and intense heat waves, drought, wildfires, rainfall, floods, higher sea levels, ecosystem and species losses, and possibly human suffering and death. A 2013 article in Science by Stocker shows that our opportunity to limit global warming to 1.5 degrees centigrade by emission reductions alone has passed. Our opportunity to limit global warming to 2 degrees centigrade is fast approaching, and the economy will only sustain emission reductions of about 5% per year. To limit global warming to 1.5 degrees centigrade, we've got to remove carbon dioxide from the atmosphere as well as reduce emissions, and that's subject to multiple feasibility and sustainability constraints. So what do? Can air transport become sustainable? One study looked at the possibility of increased fuel efficiency, jet fuel alternatives, aircraft design, and changes in operations, along with predictions of rising demand for air travel, and determined that there would likely be an increase in emissions, aircraft weight, and drag, which would require decades-long infrastructural alterations, immense amounts of land for cultivation, competition with food production, and alteration of existing land uses. A separate, more recent study selected 180 of 965 daily print media articles in these 3 topics, and they determined that they're all technological myths, ideas, stories, or narratives believed by many people, including decision makers, even though unfounded or false, that stall progress in aviation climate policy. Parnkut summed it up in the best way. He stated in his study that technology cannot solve the behavioral tendency of humans to be xenophobic and selfish. This is not a technological problem, it's a behavioral problem that we need to address. He established a 1,000-ton rule, which stated that for every 1,000 metric tons of carbon burned, 1 future person will be killed due to extreme temperatures, poverty, climate-based wars, and ecological catastrophes. And as it applies to this presentation, and to help us visualize this, states for every 4 typical long passenger jet flights, whatever long means, factoring in radiative forcing due to emissions at high altitudes, 1 future person will die on average. And this is within the next 2 centuries. Flying should be made more expensive by taxes and reserved for emergencies and life-saving projects. And to help us understand this and to use a precedent, he compares it to the bans on advertising for smoking. There should be, he proposes, a ban on fossil-fueled car and air travel advertising. Now, if we were to look at the ASLA Code of Environmental Ethics, we would hopefully find some support for these measures. We intend to do things to reduce greenhouse gas emissions. And we are fully engaged in addressing the climate change and reducing the organization's own carbon footprint. In the 2019 Annual Operating Plan, It states that we want to position ourselves as an organization to be leaders on green infrastructure, resilience, climate change, and sustainability. In two studies conducted by Atari, Krantz, and Weber, respondents were more likely to support policy changes advocated by presenters related to carbon emissions, energy, and transit when they perceived the presenters as more credible, sincere, and trustworthy. What made these presenters more credible, sincere, and trustworthy? They flew less, conserved energy at home, and took public transit more. By failing to do these things, our actions are conflicting with the ASLA's Code of Environmental Ethics, as well as many of the statements that come out of the ASLA. And we are setting ourselves up as individuals and as an organization and profession for attacks on our credibility, and people will be less likely to believe us when we advocate for things. How can landscape architecture help solve the climate crisis, and what is the ASLA doing? In June of 2017, the ASLA signed the We Are Still In Declaration, one of the few organizations to do so, and in doing so, made a number of commitments. One of the commitments includes measuring and making public the organization's environmental impact, and developing a plan for becoming climate neutral. Another is reducing transit and travel-related greenhouse gas emissions. Still another is to create a greenhouse gas inventory and set goals to reduce greenhouse gas emissions by a certain date. I've researched and published in many different periodicals on many different topics, including green roofs, standard time zone boundaries, Master of Landscape Architecture programs, and landscape perceptions, which I've spent most of my time on. I've learned how to do many different things, including statistical analysis, and I've served as anonymous peer reviewers for many of these journals. But the most important study that I think I've worked on is this recent peer-reviewed publication in Landscape Journal, the official journal of the Council of Educators and Landscape Architects. The article I've written and this presentation, which summarizes it, estimates the travel-related carbon dioxide emissions related to ASLA annual meetings between 1960 and 2019. In addition, it attempts to determine how these emissions may be associated with various effects of climate change, particularly regarding September Arctic sea ice loss and labor productivity losses. And these associations may help ASLA members visualize and understand the potential near and long-term consequences for which we are, have been, and will be responsible. And I'll conclude by suggesting alternative methods to annually convene our colleagues and allied professionals. And hopefully this study will help the ASLA and all of us reduce or eliminate our conference-related emissions and even everyday emissions, practice our organizational ethical code of conduct, and be perceived as an organizational role model, as we have committed to do as an organization in the We Are Still In Declaration. This presentation addresses 3 learning objectives. The first is to realize that air travel to ASLA meetings yields substantial carbon emissions that contribute to climate change. The second is to recognize the cognitive dissonance between professional values and actions to address climate change. And the third is to understand the urgent need to alter the format of annual ASLA conferences. Just how does the ASLA walk the talk on sustainability, in particular as it relates to the annual Conference on Landscape Architecture? When one goes to the ASLA's webpage and scrolls down, one finds a list of things that address the Conference on Landscape Architecture. And mainly, they state that the convention centers, hotels, and event venues, as well as suppliers, must demonstrate progress toward improving operational efficiency and reducing the environmental impact. And then they list a couple other things, beginning with reducing the print materials. Anything that is printed has agri-based inks, or they're disseminated electronically. Transportation, particularly regarding the shuttles between hotels and the conference venue, there's a carbon offset program that they've paid for. So it doesn't relate at all to travel to the conference city location, just between the hotel and the venue in particular. And then regarding registration and housing companies, there's some initiatives there to measure and control energy conservation, greenhouse gas emissions, etc. That's not very detailed, but we might state that that has something to do with organization. Then the ASLA's general contractor is a member of the U.S. Green Building Council, so it relates to repurposing materials, recycling materials, selecting materials that are biodegradable. Again, there's not a whole lot of specific information here, so it's hard to make any sort of estimation as to what emissions are saved or used and actually emitted into the atmosphere. So I can't address that in this study. And then the final thing is the ASLA being a member of the Convene Green Alliance, which was founded in 2008. It was then purchased in 2010 and again in 2016, but it no longer seems to exist. And there are many, many different green meeting organizations and certifications, and so many, in fact, that literature on this topic seems to indicate that there are too many as to be confusing and to make them generally meaningless. So let's address carbon offsets as it relates to the shuttle program between the hotels of the conferences and the conference venues. So Kevin Anderson, who is part of the Tyndall Center on Climate and a well-known climate change researcher, notes in a Nature commentary in 2012 that carbon offsets are worse than doing nothing. Why? Because they lack scientific legitimacy, they're misleading, and they contribute to a net increase in the absolute rate of global emission growth. Why? They don't alter behaviors at all. People pay to keep doing something that is high energy and carbon intensive, and they do not prevent CO2 from entering their atmosphere. And if you recall, not only do we need to reduce emissions to zero by 2050, we also need to begin extracting, removing CO2 from the atmosphere, and there's no proven way to do that. So why are we continuing to pay someone else or some company to change their behaviors when we are responsible for emitting these emissions? So the ASLA has presented much of this information in their conference literature that's disseminated by the mail or on their websites, including in 2018 for the Philadelphia conference. So it's shown here. And even in 2019. Again, we're focused on printing, we're focused on the conference location and what that particular venue does or doesn't do, as well as the hotels and even the expo, trying to use some of those materials from the expo, incorporate them into a project somewhere in that conference location, that city. Let's look at the 2020 Conference on Landscape Architecture, which was scheduled to be held in Miami and of course was canceled due to the COVID-19 pandemic. But this language here, the paragraph at the top, was presented almost verbatim on the ASLA's webpage. What does it focus on? So this Miami Beach Convention Center does things like collecting rain, storing it, using it in the cooling towers, using reduced flow water fixtures, implementing sun shading, daylighting public spaces, using LEDs and light sensors, saving 200 existing trees and planting new trees, and reducing energy consumption. All sounds wonderful, right? Well, if you consider that the ASLA's Conference on Landscape Architecture would have been one of 32 total events over the course of the year, and only count for about 1% of the calendar year, or less than 3% of the active conference days. This is before many of these events were canceled and postponed or rescheduled. We are responsible for very little of that operation in the hotel venue, but we are responsible for the travel-related emissions of getting thousands of landscape architects, 6,500, to that conference center. There is some existing literature that's informative in terms of comparing the carbon emissions of travel to other things that are associated with conferences. So if we look at Hischier and Hilty's report in 2002, travel accounted for 96% of the energy demands and carbon emissions, and a small percentage of those participants were responsible for a large percentage of the environmental impact. And in comparison to other things associated with the conference, like organization and some of the materials, the booklets, the bags, programs, the swag, only less than 5% of the emissions were related to that. And Stoll in 2008 looked at atmospheric scientists over the course of 2 years and found that air travel accounted for 90% of their emissions. but hotel use and ground transport only accounted for between 5 and 3%. That's it. Most of the emissions are associated with travel, air travel in particular. And there are a number of studies that either preceded that or followed that have looked at it in all different groups of people, whether it's medical professionals, geographers, agricultural economists, and as I said, atmospheric scientists. They're all, even tourism and hospitality, lots of different venues. So this study that I'm presenting now is not new. It is not unique. Well, it is unique in a few ways that I'll get to, but it's been done before. And there's lots of comparisons that could be made, whether it's from the total number of people that participated and flew by air, or the total number of emissions, or the mean. So who benefits from conference travel? One study, published in 2019 by Wynn and others, found that professors and associate professors had significantly higher mean air travel-related carbon emissions compared to others. They also found a direct correlation and a significant correlation between travel-related emissions and salary, meaning the more one made, the more they emitted. And one possible reason for that is the higher the salary, the more likely that person is to opt to fly in business class or first class as opposed to economy. And another finding was that travel-related emissions did not correlate with the average number of authors per publication, which seems to indicate that one who flies to conferences and justifies it with the possibility of collaboration and meeting others is just unfounded. Distances traveled by respondents in other studies have not related to the general environmental awareness scores of those respondents and the pro-environmental attitude and concern for climate change. The number of flights taken has not predicted respondents' self-identity as someone who is pro-environmental. Significantly differed between flyers in green academic units and non-green. And generally this from Alcock and others, practicing pro-environmental household behaviors did not relate to flight behaviors. So there seems to be this general understanding that people do not associate flying with something that is anti-environmental as an attitude and make the connection between climate change, carbon emissions, flying, and the behaviors and actions of that individual. Here are the studies that I cited here. And I want to note that Alcock and others, the first one, see the title, Green on the Ground but Not in the Air. It's a terrific title. And I'm borrowing that and modified it a little bit for the title of this presentation. So overall, what do these previous study results imply? The first is that many business and conference-related emission estimations have been conducted over at least the last 18 to 20 years. The ASLA has not, to my knowledge, and given what's available on their website, conducted a similar inventory of emission estimations, and specifically not related to the conference. So that's what this study is undertaking. Any effort by the ASLA to reduce conference-related emissions has had a minimal impact. So I'm referring again to disseminating information electronically and reduced printing or the use of agro-based inks. We're also talking about the U.S. Green Building, the contractor for the ASLA being a member of the U.S. Green Building Council and repurposing recycling materials and selecting biodegradable materials. I'm talking about selecting hotel and conference venues that seem to demonstrate some environmental awareness and trying to reduce the impact and carbon footprint in these locations. They all have minimal impact in relationship and in comparison to the travel of all these attendees to the conferences each year. Established academicians and practitioners would be more likely to participate as and benefit from being conference presenters. So these are principals, full professors, tenured associate professors like me who travel to these conferences, and they're more likely to present, and it makes sense because they have a lot more knowledge and experience, possibly in comparison to entry-level folks and assistant professors. But they're also more likely to have higher carbon footprints than others and they have more power to enact change and model behaviors that may convince others to practice their own behaviors and adopt attitudes that differ. And then finally, many people do not associate being green with opting not to fly or flying less. There's a disconnect that occurs. They think often that recycling is enough, recycling at home, when in fact has a small impact, or changing light bulbs or other things like that have a small impact on one's carbon footprint and role in climate change and all of the consequences associated with it. There's three reasons that led me to view emission estimations of featured speakers at education sessions as proxies for emissions from all meeting attendees. First, education session featured speakers' names and institutions from relatively recent annual meetings are available online or in print. Identifying and collecting information from a representative sample of prior meeting attendees would be difficult, if not impossible, to accomplish. The second reason is that there's just more education sessions. There are about 117 over the years that I looked at, in comparison to about 2 general sessions, 10 to 15 field sessions, and about 5 workshops. And the third reason is that education session featured speakers originate from across the US and the world, unlike field session speakers who live and practice near the meeting location. So how did I determine the points of origin for these education session featured speakers? So the first thing I did was collected as many annual meeting handouts and visited as many annual meeting websites as I could. So I had 2 hard copies from 2018 and 2019 of program meetings, and most of it was collected from Asla meeting websites. From those, I got the names of all the education featured speakers, as well as, in many cases, the institution that they might be representing, whether it's a municipality, a university, or a firm or an office. If I didn't have that information, the city and state associated with it, I might have gone to a LinkedIn page, visited office, municipality, university websites, or just performed some general internet searches to determine where any of these education session featured speakers were at any given time, be in 2011 or between 2013 and 2019. I had to make some assumptions about the mode of travel of these speakers. And the first is that anyone who may have had to travel a distance that was less than or equal to 1 hour from their point of origin to the meeting location, I assumed that they were local speakers and their emissions equaled 0, which of course is not the case. They likely emitted some emissions, whether it's by driving a car or taking mass transit, but I nonetheless assumed it was 0. For anyone whose distance equaled about 1 to 3 hours of travel time between their point of origin and the meeting location, I assumed they took a car. And I used a 2013 Toyota Camry, which was the most popular car in the US at that time in 2013, for all car travel. For any travel that may have resulted in 3 to 6 hours of time on the road, I assumed, if available, that featured speaker took a train. And mostly the featured speakers that originated from the East Coast locations and attended meetings on the East Coast, I assume did take train travel, which is more abundant, it seems, than in other parts of the country. And then finally, for any travel that exceeded or equaled 6 hours of time, I assume that person traveled by air. There are a number of online carbon calculators that exist. I selected 2. Carbonfund.org has one that was available through the Amtrak website. It's no longer available. The second was the Carbon Footprint Calculator, which is based upon a methodology in 2018 conversion factors defined by the government of the United Kingdom. This calculator uses the Great Circle method to determine distances between airports, as well as an 8% distance uplift factor to account for indirect aspects of each route, such as delaying an airborne aircraft. I estimated speakers' emissions with and without radiative forcing factors of 1.8791 for the carbon calculator and 2.7 for the carbon fund calculator to account for the global warming potential of emissions at high altitudes. To compile a list of ASLA meeting locations between 1960 and 2010, I went to my university library and went into the old issues of Landscape Architecture Quarterly and Landscape Architecture Magazine. And from there I compiled a list and verified this list with the list of meeting locations provided by the ASLA Library and Archives, as well as the meeting attendance numbers. I familiarized myself with some scientific literature that would help me better understand the impacts of these travel-related emissions and communicate them to others. And one article that I came across found a direct correlation between 1953 and 2010 of carbon emissions and September Arctic sea ice loss. So that direct correlation was for every 1 metric ton of carbon emitted into the atmosphere, approximately 3 square meters of September Arctic sea ice has been lost. That's easily related to the travel-related emissions of conference attendees who may have traveled by air in particular, within approximately the same period of time. So I'm again looking at 1960 to 2019. A more recent article in 2018 by the same authors, Knotts and Strove, found a similar, verified this relationship and extended it by finding a direct correlation between emissions and winter Arctic sea ice of a 1-to-1. For every 1 metric ton emitted, approximately 1 square meter of winter Arctic sea ice has been lost. In addition, I wanted to understand how many trees it would take to sequester meeting-related emissions as it pertains to travel. So I went on the National Tree Benefit Calculator's website, and there's a number of trees that are available, and I found that generally evergreen trees have a low ability to sequester or avoid carbon emissions, but some deciduous trees, such as a sugar maple, can reduce, as it shows here, atmospheric carbon by about 53 pounds in both sequestered and avoided through energy reductions. So this is a 3-inch sugar maple over the course of 1 year. So then I could calculate using this weight, 53 pounds, how many trees over the course of 1 year and a 3-inch caliper sugar maple it would take to reduce the atmospheric carbon emitted for each conference or conferences collectively between 1960 and 2019. But I was also interested in longer term. And for that, I turned to a life cycle carbon dioxide inventory of the Million Trees Los Angeles program in the International Journal of Life Cycle Assessment by McPherson and Kendall. This is one of the tables extracted from that article. And over 4 years, about 91,000 trees were planted, and they collectively they had the potential to collectively sequester over 98,000 metric tons of carbon from the atmosphere over a 40-year time period. That's what this table shows. Of those, about a third would survive that 40-year time period. So from that, I was able to take the number of trees planted initially in that 4-year period and divide it by the estimated potential sequestration over 40 years to get a multiplying factor, which I can then multiply by the total carbon estimation for either one meeting or, again, collectively over a long period of meetings to determine how many trees might be needed to be planted to, over 100 years, collect carbon emissions and sequester carbon related to meetings. There are a number of limitations for the study. It's not perfect, and it is an estimation. The first is that these estimations are based primarily upon the education session featured speakers in 2011 and 2013 through 2019. This is very detailed information, and there was a total of 2,821 speakers that have been cataloged. So a longer term review of this and any additional information about meeting attendees on a larger scale would refine these estimations even further. Second, some of the featured speakers may not have presented, may have been replaced by someone whose travel resulted in more or less carbon emissions, or may have presented remotely. And I can tell you by attending the 2018 conference in Philadelphia that at least one person did present remotely. So there may have been more, which could have reduced the carbon emission total estimation that I present, or depending upon who may have replaced a speaker, could have increased those estimations. Their travel mode may have differed from my assumptions. They may have tolerated longer car rides, longer train rides, or not tolerated those things, train or a car, and may have wanted or preferred to fly for shorter distances and durations. They may have selected a business class or first class, which would have increased those estimations even further. The featured speakers' car models and years likely varied. They definitely varied from 2013 Toyota Camrys. Not all of these featured speakers drove those cars. So there's going to be some variation in terms of any car travel related. And I did assume a uniform modern rate of fuel use, particularly for airplane travel. So one article I cited showed a 1.5% increase per year in aircraft fuel efficiency, which means that if I were to factor that into my estimations from 2019 to 2000, or at least the date of the article, which I think was 2010, back to 1916, and increase those estimations by 1.5% would result overall in a higher estimation of carbon emissions. And I did rely upon interpolations between meeting attendance numbers. So the ASLA Library and Archive was very helpful in compiling and searching for and finding meeting attendance numbers for many of the meetings between 1960 and 2019. And from those, I used an old tried and true method that landscape architects use. I interpolated for the most part, these increases and changes in meeting attendance numbers appeared rather uniform, which allowed interpolation to be a good method to use. And then finally, I did also rely upon percentages of airborne featured speakers and their emission values to calculate estimations for meetings that were not included in 2011 and 2013 through 2019. I assumed that the mean percentage of airborne travelers to these meetings and their emission values, the mean emission value of these featured speakers in 2011 and between 2013 and 2019 could be applied to all other meetings that were not included. So that's 2012 and meetings between 1960 and 2010, with some exceptions. If there was a meeting location that was already represented in 2011 and between 2013 and 2019, I used the emission weights of those featured speakers as well as the percentage of airborne featured speakers. I applied those to the meeting attendees on the whole. One of the first things I found was a relationship between the number of presentations an individual gave and their carbon estimations that are associated with that. I created this graph where each diamond represents an individual. And I focused only on those individuals, which turned out to be about 469, that presented more than once. And of these, so there's a direct correlation, which means the more you presented, the more you emitted, which makes sense. More than half of these repeat speakers participated in 2 education sessions. 85% participated in 2 to 5 sessions. Another 10% or so participated in 6 to 8 sessions. So of the 110 who gave 5 or more presentations, 86 presented as principals, presidents, directors, partners, or similar upper leadership in private practice. 2 presented as senior associates, and 10 presented as professors or associate professors. 6 were directors of foundations or public entities, and 3 were associates in private practice. So these are people who have a great deal of power. They're representing themselves, but also their firms or institutions. And these are people who are most susceptible to these attacks that could occur to their character because of the carbon emissions. This is the information that Atari and others pointed out in their 2 articles. So they also have the ability to influence others, particularly those people who are working of a lower rank within their institutions, who look up to them. And these individuals here who are presenting repeatedly have an opportunity to model different behaviors and serve as models for others in the future and show that it's okay to not fly to present at one of these conferences. I also found a significant direct correlation between the number of presentations assigned to an institution and the carbon emissions, which means that the more an institution was represented throughout these conferences that I looked at, the higher their carbon estimations in total. So I created another graph which is very similar, where each diamond represents an institution. There were at least two instances that were not graphed here because they presented 66 and 67 times, one for 12.47 metric tons of CO2 and the other for over 30 metric tons of CO2, which is off the charts here. From 2011, 2013 to 2019, the number of speakers hovered around 350. San Diego was kind of low. And the range of carbon estimations without radiative forcing went from 104 to 144 metric tons per year. And it varied, of course, depending upon the conference location. And the means per individual ranged from about a third of a metric ton to just over 4/10 of a metric ton. Why do these numbers vary between conferences one year and the next? And it really has to do with location and how far people travel, these education session speakers. So when I organized it by means of travel, you find very clearly that most people traveled by air. On average, 279 education session featured speakers traveled by air each year, and a small percentage traveled by car and train. Now, there are some exceptions. Philadelphia, there was approximately a good deal of people that may have traveled by train, and the same thing in Boston because of the access to Amtrak in the Northeastern Corridor. But you can't say the same thing in other parts of the country. But then when you compare that to the emissions that are associated with each travel mode, you see by far that air travel contributes the greatest amount of emissions in comparison to car and train. And then I was also able to sort the data according to the city of origin for each conference, and then calculate a mean for that, each city, and then organize it by the most represented by city. And New York comes out on top repeatedly, and many of the large cities, Boston, San Francisco, Los Angeles, and so on, are represented most in these. And on average, there's about 70 to 72 number of cities that are represented each year. I was also able to isolate and sort by international travel as well as intercontinental travel. Each year, the international air travel of 6 to 18 speakers accounted for 8 to 16% of education session speakers' total emissions. Overall, international travelers each were responsible for, on average, about 9/10 to 1.23 metric tons of emissions, which is about 3 times the average for all speakers combined in 2011 and between 2013 and 2019. In order to keep global warming to 1.5 degrees centigrade, we've got to remove CO2 from the atmosphere, and the best way of doing that is with trees. So, given the 9 meetings between 2011 and 2019, how many trees would we need to remove the CO2 from the atmosphere related to travel to these conferences, particularly by air? Over 1 year, we'd need greater than 69,000 3-inch sugar maples on average per year, or over 625,000 of those sugar maples in total. We could alternatively spread it out over 100 years. How many trees would we need then? We'd need greater than 1,560 maples per year, or greater than 14,000 maples. Between 1960 and 2019, ASLA annual meetings occurred in Ontario, Canada, the District of Columbia, and 25 U.S. states, including Hawaii. Past ASLA annual meetings occurred in 9 of the 10 most popular global conference locations, which are all in the U.S. except for Beijing. 31 of 60 ASLA meetings occurred in coastal U.S. locations that result in high-level carbon emissions from cross-country air travel. Cities in Hawaii, Connecticut, New York, and Washington each hosted 1 meeting. Massachusetts and Oregon hosted 2. Texas hosted 3. Florida, Pennsylvania, and the D.C. area hosted 4. And cities in California hosted a total of 9 meetings. Now, if we take a look at Table 5, which compiles the meeting location, the number of attendees, attendees by air, and the various carbon footprint estimations, including radiative forcing. I want to explain a few things about this table. So first, the number of attendees. If they're shown in bold, that number was given to me by the ASLA's Library and Archives. Number of attendees by air is emboldened. I got that number from the mean number from the education session featured speakers of that particular conference. The percentage, that is, and multiplied it by the number of attendees. And to get the carbon footprint and carbon fund numbers, I took the means of the education session featured speakers in those years and multiplied it by the number of attendees by air. Radiative forcing, again, has to do with the emissions and the additional greenhouse warming potential because of emissions at high altitudes. For every 1 metric ton of emissions, there is a direct correlation of losing 3 square meters of September Arctic sea ice. So there's an article published in 2019 which found a robustly linear relationship between cumulative carbon dioxide emissions and labor productivity loss in agriculture, mining, and quarrying, manufacturing, and construction due to increased heat exposure, particularly in equatorial regions. For every 1 trillion metric tons of CO2 emitted, global labor productivity decreases on average somewhere between 1.84 and 3.61%, depending upon the climate models you're looking at. And based on 2011 international dollars in purchasing power parity, which has a relationship to the US dollar, this represents an annual loss of 59 cents per metric ton. And these losses are most likely to occur in lower income and middle income countries where productivity losses range from 3 to 6%, depending upon the simulation. So I was able to take this direct relationship and multiply the emissions associated with each conference by 59 cents, and then I adjusted for inflation, and you come up with a dollar figure for how that particular conference and the air travel related to it might inform the labor productivity losses in lower to middle income regions in the future. Again, to keep global warming to 1.5 degrees centigrade, we've got to remove CO2 from the atmosphere. And the best way of doing that is to use trees. So if we look at the ASLA meetings and the travel-related carbon emissions associated with those meetings between 1960 and 2019, we ask, how many trees will it take to remove that CO2 from the atmosphere? Over 1 year, we need greater than 1.91 million 3-inch caliper sugar maples, or their equivalent in total. Over 100 years, if we've got the time, we'd need greater than 42,500 maples. So what's all that CO2 we've kicked up into the atmosphere going to do to the September Arctic sea ice? How much are we going to lose? Keep in mind that 3 square meters is equal to about 1 full sheet of plywood, 4 foot by 8 foot. So between 1960 and 2019, there's been a September Arctic sea ice loss associated with the travel-related carbon emissions of these conferences between 115,000 and 157,000 square meters, which is equal in area to the reflecting pool on the National Mall, beginning in front of the Lincoln Memorial and extending past the Washington Memorial to 4th Street Northwest, 1 block away from the reflecting pool at the National Capitol. So now that I've completed this study, let's reflect on it. So is the ASLA meeting its own code of environmental ethics, particularly regarding greenhouse gas emissions? No. Is there evidence that future conferences will happen and future emissions related to travel to those conferences will happen? Yes. The ASLA was planning to have the annual conference on landscape architecture in Miami this year, but it was canceled due to COVID. Are they planning one in 2021 in Nashville? Yes. Are they planning one in 2022 in Seattle? Yes. And as a result, the social consequences will continue. Those future labor losses, which can be measured in purchasing power parity, will continue. We will continue to lose September Arctic sea ice loss as it's associated with the travel-related emissions if these conferences continue. So what do we do? We have to stop emitting. We have to stop releasing CO2 into the atmosphere. There is no way to stop it. There is no way to remove the CO2 from the atmosphere, even though the special report on global warming of 1.5 degrees centigrade makes it very clear that we have to if we're going to limit global warming to 1.5 degrees centigrade. Trees can't do it. It's the most effective method, but trees cannot do it. We just don't have the quantity to do it. We don't have the numbers. Carbon offsets don't work. They still allow CO2 to enter the atmosphere. So what do we do? What should the ASLA do? Well, there are a few things the ASLA should do. And the first thing is to introduce anonymity to education session submissions, evaluations, and selections for future ASLA conferences. This doesn't really have anything to do with travel-related emissions, but one of the findings is from this study that education session speakers repeat again and again and again. We're seeing many of the same people present again and again and again based upon who they are, their title, or their institution. And this might be an opportunity to allow entry and mid-level professionals to participate in the conferences. This is an issue about equity. And I also found that between 6 and 18 of education session speakers each year are hailing from international locations. But the percentage of their emissions per year as it relates to travel is between 8 and 18%. So these people don't necessarily need to come to wherever the ASLA Conference on Landscape Architecture is, especially given the circumstances and the climate crisis. As Parnkit said, travel by air should be reserved for life-saving emergencies. Our conferences are not life-saving emergencies. Therefore, international speakers, which on the whole between 2011, 2013, and 2019 accounted for emissions that equaled one conference, or at least the sessions, the education session featured speakers of one conference. So let's let them participate, but let's let them participate remotely via telecommunication software. We've got to also acknowledge and allow speakers who present less or choose to participate remotely on the grounds of carbon emissions. So this should not, if a speaker wants to present and has the content to present that should be seen by our colleagues, they should not be ruled out simply because they refuse to travel to the conference location. What else should the ASLA do? So they should expand the use of Digitel or other equivalent software for annual conferences. So Digitel is the platform they've been using to present a lot of their webinars. But as we know, there are, certainly now that COVID has hit us, there's a lot of other platforms that may be used to expand that virtual delivery of information and courses for continuing education units. We've got to identify and utilize regional hub locations. This is a big thing, an important thing. Number of locations that education session speakers hailed from were quite concentrated in large urban areas. And based upon those, we can identify that there should be one or more hubs in the Northeastern Corridor, in the Midwest, in the Deep South, Texas, the Mountain West, California, and the Pacific Northwest. These are all cities where one or more speakers repeatedly originate from. And there are additional reasons why this should be pursued, these regional hub locations, in conjunction with the use of a virtual delivery. One of them is that I've gone through the 2018 and 2019 exhibitors that participated in the expos and found that many of them originate from the same locations as the education session featured speakers, which means we have additionally more of these expo representatives coming from the same locations. So if we have these hub locations in regions, there is a potential to have regional expos as well. But if you look at the Bureau of Labor statistics, you also see that many landscape architects are concentrated, this is just support for my finding, that many of these landscape architects are indeed concentrated in these urban areas. And additionally, the SLA's climate action presentation with President Wendy Miller identified a number of different regions wherein there will be climate action committees or subcommittees. And these seem to, although they're not perfect, but they roughly coincide with the same locations and regions that I had identified based upon the origins of education session featured speakers, as well as the previous information, the expos, and where most LAs are concentrated in the United States. So these are locations where each region is going to have to adapt in certain ways to address the climate crisis and identify unique problems and ways to try and solve them. So for instance, in the Pacific Coast, they're dealing right now, and they have been dealing with wildfires. Now here in Pennsylvania, where I am, we don't have to, at least in the Philadelphia metropolitan area, we don't have to deal with wildfires. But in the future, we may be dealing with sea level rise, as will the people in the Southeast Coast or the Gulf Coast. So these are unique conditions. Do I need to hear and learn about wildfires and how we might be able to adapt the landscape? It might be interesting to me, but more important are the issues that my region and the people living in it and my colleagues are practicing in. That's what we need to hear about. So these regional hub locations can nurture that and advance that idea. There is a number of precedents, one of which is the Nearly Carbon Neutral Conference, which is delivered almost entirely, if not entirely, virtually. This is by Hiltner. So basically, what happens is a lot of what's happening for this conference, as well as potentially the ASLA's revision conference immediately following the Pennsylvania-Delaware conference. So speakers record their own talks, and then you all view them on a website, and you participate in a Q&A session following that. There's some benefits that Hiltner outlines. The first is that it may increase attendance numbers and the diversity of people who may attend, whether it's rank, whether it's race, whether it's economic status. More people may be able to attend because you're removing some of the costs of travel and hoteling and those sorts of things. It may be more accessible. It may be easier to turn the volume up, get closer to things, go back, pause, move forward, see things, but also physically access the information. Some people may not be able to travel to Miami and the convention center there to attend the ASLA Conference on Landscape Architecture. There may be more discussion, and again, this is based upon Hiltner's findings, more discussion in comparison to the traditional conference format where attendees have to walk up to the microphone, wait their turn in a limited amount of time and ask a question. It may reduce production costs. I think we're experiencing that in our state chapter here. And there may be a more efficient use of attendees' time. So you're removing, again, the time that's needed to travel, as well as the costs, to and from a conference location. And you still have an opportunity, whether you like it or not, to spend more time with the people you live with. So I'd like to end by sharing a couple quotations from Wendell Berry. And these quotations are responses to letters that he received following an article that was published in Harper's in 1988. And although it was 1988, 32 years ago, the quotations are still relevant, as are the sentiments within them. To the extent that we consume in our present circumstances, we are guilty. To the extent that we guilty consumers are conservationists, we are absurd. But what can we do? Must we go on writing letters to politicians and donating to conservation organizations until the majority of our fellow citizens agree with us? Or can we do something directly to solve our share of the problem? I don't think that the government and the conservation organizations alone will ever make us a conserving society. Why then is not my first duty to reduce, so far as I can, my own consumption? As Americans, we are the highest, some of the highest emitters in the world, and maybe we are more responsible for the consequences of these emissions than others are in the world today. But we have an opportunity to act and to show others and to actually lead and do good by our own behaviors and show others what the right thing to do is. as individuals, but also as a profession and an organization. Join me.